Okay, we're doing the first type of induction again. Now we're on question 5. So we have to prove that 1 over 4 times 5 plus 1 over 5 times 6, etc. Plus 1 over n plus 3 times n plus 4 is explained by n over 4 times n plus 4. So remember, it's just this part that I'm interested in. So first of all, let n equals 1. I fill in n for 1 and I get 1 over 20 equals 1 over 20. So it's true for n equals 1. I assume it's true for n equals k. So write out my series and fill in k for n at the end. Perfect. Then I have to prove true for this. So all I'm putting in for n this time is k for k plus 1. Perfect. So we always start our proof with our assumption. So I rewrite my assumption. And now here we go. Onto both sides of my assumption, I had to add on the next term. So look at the left side. I'm going up as far as n equals k. So I'm just going to add on the next term now, which is where n is k plus 1. So that is 1 over k plus 1 plus 3 times k plus 1 plus 4. And if I add that onto the left, I also have to add it onto the right. So plus 1 over k plus 1 plus 3 times k plus 1 plus 4. Okay, so I can rewrite my my left side now exactly like my proof. So it's 1 over 4 times 5 plus 1 over 5 times 6, and I'll just skip all the way to the last term in that sequence, or that series, sorry. 1 over k plus 1 plus 3 times k plus 1 plus 4. So that's my left side sorted. This is exactly the same as the left side of what I have to prove. Now I just need to make these two right sides exactly the same as each other. So let's look at what I have up here. I have a 4, I've got a k plus 1 on top, okay, so I'm going to keep an eye out for him. I've got a 4 down here outside the bracket, so I'll just keep that in mind. I won't be multiplying in any 4s if I can avoid it. Look, I have that 4 down here, I can see him here. So I'll tell you what, we start off anyway. We've got one fraction, what we have to prove, so let's get one fraction here. But we'll start by tidying up. So that's k over 4 times k plus 4. Again, I'm not multiplying in that 4 because I can see in what I have to prove that I have the 4 outside here. Okay, so tidying up my blue part here. So k plus 1 plus 3 is just k plus 4. And k plus 1 plus 4 is k plus 5. Okay, so I need a common denominator. So the easiest thing is I've got a 4 here, I've got a k plus 4 here, I've got a k plus 4 here, and a k plus 5. So if I just write it out so that everything in my common denominator is going to appear. So I've got 4 times k plus 4 times k plus 5. Perfect. So all of this appears in my denominator. Perfect. And of course, all of this appears in my denominator. Makes it a common denominator. So what does this k have to get multiplied by? Well, 4 times k plus 4 changes into 4 times k plus 4 times k plus 5. So that has to be multiplied by k plus 5. K plus 4 times k plus 5 has to be multiplied by 4. So my 1 has to be multiplied by 4. All right. So we tidy that up a little bit. On top, we go k squared plus 5k plus 4. All over 4 times k plus 4 times k plus 5. And I'd imagine you see where this is going. So what do we have here? Let's just check on our proof. I've got in my proof, in what I need to prove, I have to have 4 times k plus 1 plus 4. Now k plus 1 plus 4 is k plus 5. So I have it down here. I've got my 4. And I've got my k plus 5, which I'll break up in a minute. But I can factorize my top, and I bet you some cancelling will happen. So that is just going to be k plus 1 times k plus 4 on top. At the bottom, I've got 4 times k plus 4 times k plus 5. Just like in the previous one, I can see my k plus 4s disappearing. Well, not sorry, disappearing. Nothing disappears, dividing in. Leave me with k plus 1 over 4 times k plus 5. And then just to be super duper clear, because I want to write it exactly what I need to prove, k plus 5 is k, how was it written above? It is k plus 1 plus 4. Okay, so k plus 1 plus 4. Perfect. And then, so it's true for n equals k plus 1. And please finish with the correct conclusions then, just like I did in the previous video.